So, we're going to be using multi-digit multiplication. We're going to be using the standard algorithm. Okay, how many of you do like the standard algorithm better than the other ways we've learned so far? That seems to be your favorite so far. Most of us, a lot of us. Okay, like I said, after fall break, we've got, I think, one more different way that we're going to show you that will be used at different times, called the area model. And we'll work with that for a little bit, but we're going to mostly be using standard algorithm from now on. So let me switch over to right here. You know what? I really like the warm-up better on this one. Let me switch back over for that, and then we'll jump back into 12. We're kind of going to go back and forth between 12 and 13. Bless you. Okay. So we're going to start here, and just to kind of get us going and thinking in the right direction, we're going to just start with some standard algorithm multi-digit multiplication problems and get some practice there. Here we go. So if you would, on your board, write that, rewrite that, but we're going to rewrite it vertically. So you're going to turn it, of course, this way like we have been working on. And go ahead and solve that. I'll give you just a minute to do that. And then we will check it. He sees the way I am. We're doing all kinds of things. We just, got too much going on. That's what I figured. Okay, let's see what we've got. Okay, looks like most of us are finished with that one. So, we won't go through every one of these this slow. Okay, but just let us know. Remind us with words how we start one of these. Okay, because even though that to some of you that might seem like the simplest question, to some people that's where they get confused. Where do we start here? What numbers do we look at first, and we know that's where we're going to start?
The 3 times 2.
Yes, we know we're going to take that 2, and that's like always where you start, right in that little corner. And you're going to take that 2 to each of these places. So 2 times 3 is what, everybody? 6. Then we're going to go next door to the tens place. 2 times 7 is
14.
So Caleb, what am I going to do with that 14?
You put a 4 down, and then you put a 1 above the 7 next door.
Why would I carry the 1 and not the 4? Let's get that understanding. Why?
Because it's 17 and it will equal 140.
Okay, but what else about that 14?
It's too much.
It's too much. That 1 is really a bundle of what? 10 that we're carrying next door because it's too much to sit right here. So there we go. Okay, I've put my 4, I've carried my 1, and what's our last step, Brandon? What would we do here?
We'll do 2 times 7, then add the 1.
Okay, 2 times 7 again, but we got to remember to add that 1. I'm glad you said that. So 14, 1 more would be 15. Okay, so if that is not what you got, I want you to look. Can you figure out what you might have done? Anybody get that for their answer? Show me if you got that for your answer. Yeah, a lot of you had that. Okay, good job. All right, go ahead and clear that off, and we're going to move on. We're going to do a couple more of these just to get us going, get this back in our head, and work off. Okay, go ahead and work with that one. 1,605 times 3. See what we've got here. Let me rewrite this. 1,605 times 3. Alright, so let's just answer these multiplication problems inside of this together. 3 times 5, everybody, is 15. I'm going to put the 5. I'm going to carry the 1. Ooh, the big bad 0. 3 times 0 is what?
0.
0. 3 times 0. Anything times 0 is 0. So 3 times 0 is 0, but I've got to add what's up here?
1.
So 0 plus 1 is 1. Okay, 3 times 6?
18.
Okay, we're going to try that one more time. There's not going to be this long pause. Okay, ready? 3 times 6?
18.
Much better. I'm going to put that 8. I'm going to carry that 1. 3 times 1 is 3. Plus 1 more is 4. Okay, 4,815. Okay, saw that in a lot of places. Yes. Okay. Okay, clear this off. We've got one more practice. They're being really nice to y'all. They're being really nice to y'all with this number right here. Okay, go ahead and try 5,741 times 5. Alright, let's go over this. I feel like most of us are finished. If I turned this, it would look like this. 5. Alright, 5 times 1 is 5. 5 times 4. Put the 0, carry the 2. 5 times 7, 35, 36, 37. Okay, put the 7, carry the 3. 5 times 5, 25, 26, 27, 28. Okay, 28,705. And I saw that on most boards, most places. Okay. Can any of you feel yourself getting faster with this way of doing multiplication? Can you? I see it happening slowly. Okay, and so you are getting better at all of this. Okay, so if you don't feel like it, are we still going to make mistakes? Yes. I was working a problem in there yesterday afternoon, and I made a mistake, and we got it corrected. But it's because I was in a hurry. So I say that to tell you, it doesn't matter how old you are, it doesn't matter how long you've done this, you're still going to make mistakes sometimes. Okay? I know what to do, but I got in a hurry. So we just all have to be careful sometimes. Okie doke. So I know why they were so easy on us, because now, let me switch this. Dun, dun, dun. No, I'm just kidding. No, we don't want this to be something scary. I don't want this to be something that we dread. It's just the same type of math. Different look, different form. Okay. So for right now, I do want you to put things away. I do want you to put the top on your marker. I want the marker, and just like Alexandria's desk right here, this is exactly what we need to look like right here, where it's just left alone. Okay. It's not bothering you. You're not bothering it. Let me try something right quick. This is a little small. That's not it. Let's see. I think I have to go to view. Okay, that didn't work. Let's try. Ooh, I feel like this is going to be too big. Maybe not. Okay, maybe that's at least a little bit better. Okay, these are the actual problem set problems in your workbook today. And so, and virtual folks, if you're listening on Monday or Tuesday, when you work on this, if we have put the problem set page numbers, you may have to switch over to the homework pages, which are just a few pages over. Okay, because sometimes our practice problems are the actual problem set problems, and I don't want you to have to repeat those after we've already seen them. That doesn't really help us. So go and do the homework pages instead of the problem set pages. Okay, and we'll do that in a minute. So we're going to practice a few. We're going to work a few. And so I'll be telling you which ones to circle. Some we won't do, some we will do, and all that. But the ones we're going to do together right now for some practice are very, very, very similar to what you're going to see, okay, in just a minute when you're working more on your own. So let's move that cursor out of the way. Can anybody read that for us that can see it pretty well? Charlotte, you're right up close. Read that for us. And y'all follow along as best you can, okay?
The table shows the cost of party favors. Each party guest receives a bag with one balloon, one lollipop, and one bracelet. What is the total cost of 9 gifts?
Okay, so what's the total cost? That's what we're trying to figure out. What is the total cost for 9 guests? Now, guests, it would be somebody coming to the party, right? So those guests are 9 different people, right? And they want to make goodie bags for 9 people. So how many goodie bags are you going to make? 9, okay. Today, when we work these out, there are going to be times I'm going to say, take your board and draw a line across it. We're going to cut it in half so we have 2 spaces here. And on the top, I'm going to ask you to try and figure out, is there anything I could draw to help me see this problem better, to help me figure this problem out? Yesterday we had a practice problem that was a word problem, and we were talking in second period, and one of the suggestions when we asked, hey, what kind of picture could we draw for this? Do you remember the one we did about, it said there are 5,280 feet in a mile. Joe ran 4 miles. How many feet did he run? I think it was. And I drew 4 squares. And those were my miles. Those didn't look like miles. It was just a square. But it was something for me to see to know, okay, I've got 4 of those. So somebody suggested yesterday that, sometimes what you draw might be like a chart. It might just be putting down your important information. And so what we draw to figure out our problem might be different at different times. It may not always be shapes. Sometimes it might be words. Sometimes it might be shapes. Sometimes it might be an actual picture. Okay? And what Gage draws might be different than what Bailey draws, because he might need something different to look at to figure it out, and she might need something different to figure it out. It's okay if our boards don't look 100% the same when we do this kind of problem. Now, of course, we do want the same important information and numbers and things like that. That's not what I'm talking about. Okay, so here is this table, and it tells us how much things cost. If I'm going to buy a balloon, it's going to cost me 26 cents. A lollipop, one lollipop is 14 cents, and one bracelet is 33 cents. Okay? So each party guest is going to get a bag with one balloon, one lollipop, one bracelet. So every time there's a person, they're going to get all of these. They're going to get one of each of those. Okay? All right. What are some thoughts? Now, this is what we're doing today. This is our learning target, is to use our multiplication skills. We're going to pull in, sometimes it might be addition, sometimes there might be some subtraction. Okay? We're going to use all of that to figure out what to do here. We got to figure out, this is a real world thing. How many of you have birthdays? We all do, don't we? Okay? Sometimes we might be passing things out to somebody that comes to a party. So if this was really happening, we need to figure out how much money we need to get to make goodie bags. We want everybody to get all of this. So what are we going to do? What are some thoughts? What does it sound like we need to do? Yeah.
We could add up the balloon, the lollipop, and the bracelet, and then whatever we get, we can times it, like we can do 9 times whatever that is.
Okay. Good thought. We're going to hold on to that. Let me hear these other thoughts too. What were you going to say?
I think it's 9 times 26, 9 times 14, and 9 times 33.
Okay. So you've put them all together and then multiplied, and you're multiplying them one thing at a time. All right? Okay. What would we do after we multiplied them all 3? Would we put that all together? Okay. Was there another thought over here?
Yeah, I was going to say it was.
Okay. So said the same thing. Okay. Now, guys, in a few minutes, this is going to be you coming up without me. Okay. With a very similar problem to this. If everybody's going to get one of each of these, we've got to figure that out. We've got to do this 9 times. So would it be easier to add them all up and then multiply that by 9? Or to do 3 multiplication problems? Then add the answers up. Either way, we are adding and multiplying. It's just which one do we want to do first? What's your thought?
My thought is to add them all up and multiply them.
Okay, so you would rather add them up and multiply once. Okay, seeing some agreement over here. All right. Now, is it wrong to multiply each one and then add those up? No, it's not wrong. It's just your choice. Okay. All right, I am going to go ahead and do it that way also. So if we added these up, we've got 26 cents, 14 cents, and 33 cents. Okay. I'm going to add these 3 up. 6 plus 4 is 10, plus 3 more is 13. Bless you. That would be 4, and 3 more is 7. So we've got 73 cents. Make sure I did that right. 73 cents. So this equals 73. Every time we have a guest and we're giving them a goodie bag, it's going to cost us 73 cents. Okay? How many guests are they wanting to have at the birthday party? Brandon, what was that number?
9.
9. Okay? That was right here. What is the total cost for 9 guests? So right now, I want you to help me figure this out. We're going to figure out what 73 is 9 times. So if I wanted to draw a picture, if I really wasn't sure, you know, these could be my goodie bags. Each of them is going to be 73. You know, maybe I've got them spread out because I'm going to fill them up. Each of those bags is going to cost me 73 cents. And last year in 3rd grade, you talked about if I'm going to add something up, the same number over and over again, the quickest way to do that is to multiply. So, on your board, help me figure out what 73 9 times is. Okay. 73 9 times. All you're writing is what's in blue up there. 73 times 9. A lot of us are sitting there staring at our whiteboard. You're staring at this right here. I like those whiteboards. I think you do too. But let me tell you something, as nice as they are, staring at them will not make the answer magically appear. They're good, but they're not that good. If you're having trouble knowing what 9 times 3 is, and that's why some of you are sitting there staring at it, you're not sure what that answer is, practice your multiplication facts at home. I'm looking at you, and I'm looking at you. Okay? Because we should know 9 times 3 like that. What? Yep. Yep. Okay. 9 times 3. What is 9 times 3?
27.
27. Put the 7. Carry the 2. Ooh, 9 times 7.
63.
Good. Good. 63, 64, 65. Okay. So we get 657. Now, guys, you see that I'm getting a lot of stuff up here. And I've watched 4th graders do word problems before, and I know even when I've done them on the board, there all of a sudden is a lot of stuff on the board or on your paper or on your board. Be careful because you want to keep up with what is what. Now, we've got 657, but we can't stop there. We've got to label that answer. 657 what? What is this? What is this? It's cents. Now I want to kind of figure out what you know about money. If I have 657 cents, if somebody handed me 657 pennies, okay, it's a lot of pennies. think about how many pennies it takes to make $1. And what is, usually if I go into a store, I don't see a price tag on something that says 657 cents. It's usually written differently. So what would that be? Yeah.
$6.57.
Every time I have 100 pennies, that's $1. So all of these in the hundreds place are actually dollars, aren't they?
Mm-hmm.
They are. So the way we would write that, let me get rid of just this. $6, and that's actually a decimal point.
Oh.
6, and we'd put our money sign here. $6.57. Okay. Now, if you wrote 657 cents and that was your answer, I would not count it wrong. That is correct. Somebody might come in and pay with 657 pennies. They might be saving them we have a big jar that we drop change in at our house. A lot of people do that kind of thing. Hey, money's money, right? I can buy something with a penny just as much as I can buy something with $1. But if we're going to write it, I guess the most efficient way, this is really the way we would want to do it. Okay, so just a little side note there about money. Okay. Let's move on to a different kind of problem. Now, we're going to see one with a little chart like this a little bit later. Okay, I wanted you to see one as we practice together. You can clear off your board. All right, this one is going to mix in something that we saw a few days ago. Not just multiplication, but a little something extra. Remember our multiplicative comparison. Okay. All right, who can read that for us? Caleb, go ahead.
The Turner family uses 548 liters of water per day. The Hill family uses 3 times as much water per day. How much water does the Hill family use per week?
Okay, now we're going to dig in and we're going to figure that out. So if you read that at first and you go, go back and read it again. Slow down. We can figure this out, no problem. Now, a liter. We don't use that term very often. Where do you hear liter? Probably the most often. Where do you hear it? Where do you hear it? In the kitchen. Okay. Where else?
If you're measuring how much water.
It does measure water. It measures liquids. How many of you have ever heard of hey, let's go get a couple 2 liters from the grocery store of Coke, or 2 liter? That's a 2 liter bottle of Sprite. You ever heard that?
Uh-huh.
Okay. You know those bottles? I wish I'd have brought one today, but I'll bring them out when we do our measurement. A 2 liter bottle, let's say of Coke. Okay, that's 2 liters. Well, let's just stop there because I don't want to get into a measurement lesson today. But that's 1 liter, of course, would be half of that. Okay, so I'm just trying to give you an idea of how much they're talking about. So the Turner family, their whole family, 548 liters of water per day. Now that's showers, that's washing clothes, that's cooking. If they have a dishwasher, that's running the dish. That's all. It's not like just drinking water. Wow, they really drink their water, don't they? Woo, they're healthy folks. No, that's like what, using it for everything. Okay. The Hill family uses 3 times as much water per day. How much water does the Hill family use per week? So what we're trying to find is how many liters does the Hill family use? Well, they use 3 times as much as the Turner family.
Per day.
You hear that in there? So what is our math equation, our math problem going to look like? Miranda, what would you do if you had to write a math problem for this?
I would do 548 times 3.
Okay. How many of you agree or disagree, or you have a different math problem you would write? Yeah, that's exactly what I would do as well. So let's help Miranda figure that out on our boards. Okay. She said 548 times 3 because the Hill family uses 3 times as much. And we're trying to figure out how many liters the Hill family uses each day. This one was a little easier to hear, maybe. Okay, so go ahead and work that problem out. Don't forget this would have a label, so what label do you think you would put with it? Okay, let's go ahead and work this one out. All right, I saw a lot of the same answer, and a lot of times that's a good thing. Sometimes it's not. You know what? I have, maybe I've said this before, but I have had almost the whole room get one answer, and one brave person say, no, I got a different answer. And they were the one that was correct. You know, that's hard sometimes to be that one person who's got something different and to share that answer. But that day, woohoo, that person was correct. Okay. 3 times 8, 24. With the 4, carry the 2. Okay. 3 times 4 is what? 3 times 4 is what?
12.
Here we go. Plus 2 more would be 14. So put the 4, carry the 1. 3 times 5?
15.
3 times 5?
15.
Plus 1 more is 16. Okay. Now what are those? 1,644 liters. Now you could have written the word liters. Good practice if you did. The abbreviation for liter is just an L. A lot of times people will put a capital L so that it doesn't look like an extra 1. You know, that lowercase L is tricky sometimes. Okay, so you could have just put that capital L and been fine. All right, I saw this answer in a lot of places. Good job with that. All right, our last one that we're going to practice on this chart is right here already. Can somebody read about Jaden for us? Or I can pick. You want to read it? Go ahead.
Jaden has 347 marbles. Elvis has 4 times as many as Jaden.
Presley. Mm-hmm.
Presley has 799 fewer than Elvis. How many marbles does Presley have?
Okay. All right, so guys, let me just go ahead and say right off the bat, this one takes a few steps. Okay? Now, Miranda just a second ago, we read that problem and she immediately saw the math problem to write. A lot of you did. And we didn't really need a picture with that one as much. This one, I don't need a picture so much. I'm going to show you what I do need. And I want you right now to cut your board in half. And I would turn it tall ways, what we call portrait. Okay? And at the top of our board, let's put some information, what I'm going to put here in red. We've got 3 kiddos, and they have marbles, which are those glass spheres. You know, yeah, they're all different colors. I don't see kids playing marbles as much these days. A long time ago, it was played a whole lot more, but I think it's still out there. Anyway, we know how many Jaden has, but I got to figure out Elvis's from Jaden's. And I can't figure out Presley's until I know Elvis's. So whoa. So, on the top of your board, we're going to put all 3 of these names. We're going to put Jaden, and you know what? Let's just put their first initial. Okay? We've got Jaden, we've got Elvis, and we've got Presley. Okay? if you're working and you want to write their names, fine, but you can put their initial. Do we know Jaden's number of marbles? Look at the very first sentence. We do know that. So he has 347. Okay? Now I hope by you writing this down, you're going to see that writing this down will help you figure out what to do if you're not sure what to do. Elvis has 4 times as many as Jaden. Listen to those words. Elvis has 4 times as many as Jaden. Elvis has 4 times what Jaden has. You see that? So if I work that math problem, I will know what Elvis has. So I know I got to do that. Okay? So before we go any further, before we can figure out what Presley has, we're going to stop and figure out what Elvis has because his number is going to help us with Presley's number. All right, so down on the bottom. Now, I'm going to borrow poor Gage doesn't get his board very often because I'm always grabbing it. You see how he's moved his problem over to one side? Do that on the bottom because we're going to have more than one math problem to work out down here. Okay? So right now you are doing 347 times 4. Times 4. All right, so if we have worked that out, what have we gotten for 347 times 4? What'd you get?
I got 1,388.
1,388. 4 times 7, 28. Carry the 2. 4 times 4 is 16, 17, 18. 4 times 3 is 12, and 1 more is 13. 1,388. Okay, so we're going to put that up here beside Elvis as the answer. Okay, we're getting closer. We now know Jaden's number of marbles. We now know Elvis's number of marbles. We're almost to the end. Presley has 799 fewer. What does fewer mean? Yeah. Okay, it's telling us she has less, so we're going to have to do that. She has 799 fewer than Elvis. So what does the math problem look like to figure out Presley's number? Yeah.
1,388 minus 799.
Yes. Okay, we're going to have to subtract to figure out her number. 1,388 minus 799. Are you going to have to be careful? Look at that subtraction problem. Are you going to have to be careful there?
Yes.
Most definitely. All right, take a minute and work that out. so there's a lot of borrowing happening here. We can't subtract 9 from 8. We're going to have to go next door. Let me change that just to help us see. 18 take away 9 is 18 take away is 9. Okay. 9. We've got a 7 left. That's not going to work either. So we're going to go next door and change that to a 2. 17 take away 9 is 8. Okay. 2 take away 7. That's not going to work either. So we're going to borrow from here. 12 take away 7 is, okay. So Miss Presley has 589. Our final question said, how many marbles does Presley have? So our final answer is 589 marbles. Was this other stuff part of the answer down here? No, but did we have to have it to figure this out? Sure. And so we just took this problem a chunk at a time, a little step at a time, and we finally got to the correct answer. Okay. All right. We're going to do one more practice problem. Okay. We're going to do one more practice problem. So clear your board. After that, we'll take our quick break, and then we'll move to working on our own a little bit more. Let me switch over to lesson 13. We're going to borrow some of those word problems. Okay, now I picked one of these that had several steps. So this is going to take several steps. I would like you to draw the line again across your board because we're going to write some information at the top and work our math problems on the bottom. This is tiny. Let me change the view. Hopefully that will help a little bit. Okay. All right. Yeah.
And since we don't write as much as we do on the top and the bottom, we make the top half shorter.
Yeah, great idea. If you want to make the top half smaller, a little shorter, great idea. Okay. Sylvia weighed 8 pounds when she was born. Okay, so we're talking about a baby here. She's born. She weighs 8 pounds. By her first birthday, her weight had tripled. Okay. By her second birthday, she had gained 12 more pounds. At that time, Sylvia's father weighed 5 times as much as she did. Our final question that we're figuring out was, what was Sylvia and her dad's combined weight? There are a lot of steps in this problem. Okay. So, what do we know? We know that and we can put, let me move that cursor out of the way. We can put our I'm going to put my information over here. I've split my board just the opposite. You're going up and down. I'm just putting side to side because I don't have as much space. All right, so when she was born, let's put Sylvia. I'm going to put a B for born. When she was born, she was 8 pounds. Okay? The S is for Sylvia. If you want to write her name, that's fine. When she was born, she was 8 pounds. Okay? Get this because you're going to need to stay with me. Then it says, by her first birthday, her weight had tripled. What does tripled mean? What does that mean?
Like bigger?
It definitely got bigger. Okay. Now, did you know that like in your first year. Like that's the fastest growth, like for everybody. That's the year you will have the most rapid growth and change in the way you look and so when we think about from a baby till the time they're probably walking at first, there's a lot of change. A lot of change. If something triples, how many times bigger does it get? We know it gets bigger. What does triple mean? Yeah. 3 times as much. So we might not know that, but if something triples, it's 3 times as much. Okay, so I'm going to put a 1 for her, or I'm going to put actually first. So I don't think that's like her weight. So on her first birthday, she was 3 times that. Listen to the words. She was 3 times that. She was 8 times 3. Which is what? We know 8 times 3. What's 8 times 3?
27.
24. Okay. So when she was born, she was 8 pounds. On her first birthday, she was 24 pounds. Okay? Make sure you got this written down. Let's just practice pulling out this information. By her second, why are we having to go through every birthday? Because we've got to work up to where she is to figure out where she is now. By her second birthday, she had gained 12 more pounds. Okay, first birthday, she's 24. Second birthday, she's 12 more pounds. What are we doing here? Are we subtracting? Are we adding? Are we multiplying? What are we doing?
We're adding 24 plus 12.
Yes. On her second birthday, she's just 12 more pounds. So she's 24 plus 12. All right, if you recognize your 12, 12 times 1 is 12. But 12 times 2 is 24. 1 more 12 would be 12 times 3. What is the answer here? What's 24 plus 12 is? 36. So by her second birthday, she's up to 36 pounds. Which is probably about normal. I'm not a doctor, so I don't know, but okay, so we get to stop with Sylvia right there for now. At that time, so when she was 2, at that time, Sylvia's father weighed 5 times as much as she did. All right, so now Dad comes along. How much does Dad weigh? 5 times what she is. Dad is 5 times 36. There is our multiplication coming in. So on the bottom, let's work out 5 times 36. Let's ignore it right now, please. Okay. 5 times 36. Get that worked out. Shh. Okay. Give everybody a chance to do that. Okay. 5 times 6 is what, everybody? 5 times 6. 30. Put that 0, carry that 3. 5 times 3, everybody.
15.
We're getting a little quicker. Plus 3 more. 15, 16, 17, 18. Okay. So here we have Dad. And Dad weighs how much?
180 pounds.
180. I'm glad you added the word pounds. And so that would be our final answer. No. Is it?
No.
Yes.
No. No. Yes.
Now,
No.
okay. So,
Yes.
guys, when you can find the final answer. We'll say a no. The final, not final answer, I'm sorry, the final question. What was the actual question we were trying to find? We'll read that final question for us.
What was Sylvia and her dad combined weight?
Oh. We did all of that work just to find how much Dad weighs. And now, that's not even our final answer. They want to know combined. Combined means together. Okay? So, how much was Sylvia and Dad together? Well, Sylvia's weight was 36. Dad's weight was 180. What are we going to have to do to find their combined weight? Add them together. Add them together. I can't tell you how many times I've seen somebody get almost to the end and they forget to do that last little step. They forget to, what is that last question? What is that question asking? Oh, not just Dad, but Dad and Sylvia together. Okay. You want to share the answer? Okay. What did you get?
216.
216. Okay. Some others got that as well. When we add 0 and 6, we get 6. 8 and 3 is 11. We have to remember that we are actually adding and not doing anything else. 216 potatoes. Pounds. Anybody know the abbreviation for pounds? It's weird. No.
LB.
That would make sense. What is it?
LB.
LB for one, and then if it's more than one, it's LBS. Where do they get the L and the B? I don't know.
I don't know.
LBS. I need to Google that and research that. But that's the abbreviation for pounds. Now you can write the word pounds if you don't know the abbreviation. Okay. All right, a lot of steps there. It just takes slowing down. You know what? When you work a math problem like this, you probably need to read through it 2 or 3 times just to really understand what steps you've got to take. They take practice, guys. That's why we're going to practice these all year long. Okay? All right, so we're going to go ahead and clear off your board and be putting your board away and just lay out your workbook on your desk.